All right, everybody, so this is our second set of notes. We're going to start off by reviewing what we've learned in the previous video, as well as what we've learned regarding empirical formulas and molecular formulas. We're also going to take this one step further. In the previous video, we learned how to convert from moles of one substance to moles of a second different substance. What we're going to learn today is how to convert from moles of one substance to grams of something different. So let's go ahead and recap what we should know by now. We should have a good handle on this. We spent about a week talking about how to convert from percent composition to empirical formulas and molecular formulas. So number one, it wants me to determine the molecular formula and empirical formula of a compound with 93.7% carbon, 6.3% hydrogen, and then it tells me that the molar mass of the compound is 128 grams per mole. So what that's telling me, this is telling me the molecular formula mass, and we'll come back to that here in a moment. So let's start by taking our percentages and converting to moles. So our first step, convert percentages to grams. So I have two substances. I've got carbon and I've got hydrogen. So I'm going to write carbon first. And carbon had 93.7% of carbon. So I'm going to convert that to 93.7 grams of carbon. And then 93.7 grams of carbon will then convert to moles of carbon. So in 1 mole of carbon, I've got 12.011 grams found on my periodic table. And then we'll do that calculation. For hydrogen, you've got 6.3% hydrogen, so that's 6.3 grams of hydrogen. And if at any point, let me stop here, if at any point you know this stuff, you're welcome to try this on your own and then check your answers here after I get to that point. So 6.3 grams of hydrogen converts to moles of hydrogen by dividing by 1.008 grams of that substance, again found on the periodic table. All right, so 93.7, let's go to carbon. 93.7 grams divided by 12.011 grams gives me 7.80 moles of carbon. And then for hydrogen, 6.3 divided by 1.008 gives me 6.25 moles of hydrogen. So now my next step is to determine which of these is the smaller value. So 6.25 is obviously less than 7.8, so I'm going to divide both my mole values by 6.25. So I'm going to divide this by 6.25 and then this by 6.25. All right, so when I divide anything by itself, then that gives me 1. And then 7.80 divided by 6.25 gives me 1.248. Now, 0.2 is not within 1/10 of the nearest whole number. So now I got to find a factor to multiply it by, the lowest factor that I can multiply it by to get a whole number. So you can try 1.248 times 2. 1.248 times 3 until you get a whole number. This is actually 1.248. If I multiply it by 4, then I get 4.992, which is very close to 5. So if I multiply that by 4, then that means I've got to multiply this by 4. And 1 times 4 is 4. So these are my subscripts for my compound. So my compound becomes C5H4. All right, this is my empirical formula. I'm going to abbreviate here. This is my empirical formula. Okay. So now the next step is to find the molecular formula. Well, to find the molecular formula, you've got to find the empirical formula mass first. So the empirical formula mass is the mass of my compound in the empirical formula. So I've got 5 carbons, 4 hydrogens, so I need to add those up. So carbon is 12.011, and I've got 5 of them, plus hydrogen is 1.008, and I've got 4 of them, and then add them up. So this is carbon, this was hydrogen. When I do the math, I get an empirical formula mass of 64.087. Okay, now I need to take the molecular formula mass and divide it by the empirical formula mass, and that gives me my integer for my molecular formula. So the molecular formula mass was given up above. We said it was 128 grams per mole. That's my molecular formula mass. So 128 divided by 64.087 gives me 1.997, which is approximately 2. So 2 is my multiplier. So it's 2 times, and then I had C5H4. So 2 times 5, 2 times 4. Gives us C10H8 as our molecular formula. All right, number 2. Determine the molecular formula of a compound with the empirical formula CH2 and a molecular mass of 70. So now we are given a compound of CH2, and then it gives us the molecular mass of 70 grams per mil. So I want to figure out the molecular formula based off of the empirical formula that's given to me. Okay? So the first thing I need to do is determine the empirical formula mass. So the empirical formula mass is equal to, so I've got CH2, so that's 1 carbon, so 12.011. Sorry about that, guys. There's a lot of stuff going on today. Fire drill, emergency announcements. If you were here today, today's Friday, March 6th, you know what I'm talking about. All right, so 12.011 times, there's only 1 carbon, so that's times 1, plus I want to add the mass of 4 hydrogens, or excuse me, 2 hydrogens, so 1.008 times 2. Typing that into the calculator, that gives me, let's see here, 14.027. So now I've got my empirical formula mass. Now I want to figure out the molecular formula. So I take the molecular formula mass, which was given to me as 70 grams per mole, divided by the empirical formula mass, which I just determined. You get 70 divided by 14.027, and that gives me roughly 4.99, which would round up to 5. So that means that I'm going to take that 5 and I'm going to multiply the subscripts in my formula. So it becomes 5 times C1H2. So 5 times 1, 5 times 2. My formula becomes C5H10. There's my molecular formula. Okay, so what do the coefficients represent in a balanced reaction? Well, those coefficients represent the number of molecules or the moles of that compound. The number of molecules or moles. Okay, either way. What's a mole ratio? A mole ratio is use the coefficients in my chemical reaction to compare the substances. So, for example, I've got 2H2 plus 2NO produces 2H2O and a 1N2. So I could read this as 2 molecules of hydrogen gas plus 2 molecules of nitrogen monoxide react to produce 2 molecules of water and 1 molecule of nitrogen gas. I can also, because the subscripts represent molecules or moles, I could say 2 moles of hydrogen gas plus 2 moles of nitrogen monoxide produce 2 moles of water and 1 mole of nitrogen gas. Okay, we can use those terms interchangeably. Okay, so using that reaction that's up here, we're going to determine the ratios of hydrogen to nitrogen. So hydrogen in this equation is H2, and nitrogen is N2 in my equation. So here's hydrogen, here's nitrogen. So the coefficient for hydrogen is 2. The coefficient for nitrogen is 1. So my ratio is 1 to 2. I cannot reduce that. No, excuse me. Got it backwards. It is actually 2 to 1. There we go. And I cannot reduce those any further, so the ratio is 2 to 1. Looking at hydrogen to water. So hydrogen has a coefficient of 2. Water has a coefficient of 2. So let's see here. H2O. So I got 2 to 2, which reduces to 1 to 1. All right, and lastly on this front side, what is stoichiometry? Stoichiometry is using those mole ratios from a balanced equation or reaction to calculate the ratio. My goodness, so many bells and alarms today. To calculate the ratio of the reactants or the products. All right. So some things we should maybe highlight here. Know what stoichiometry is. Determine a mole ratio, and know what the coefficients represent in an equation. Okay, so let's take a look at the back side. We'll focus on the left side first. So here, it's telling me here that this is mole-to-mole stoichiometry, and I'm given moles of substance X, and the unknown is the amount of moles of Y. And all that I need to do is give the general T-chart for a mole-to-mole calculation. So based off of the information that's given to me and what I need to solve for, my T-chart might look something like this. So I always write the given information on the top left. So whatever amount of given information I have, that amount of moles of substance X. Okay, I always bring down the unit. So it's an amount of moles of substance X, and that converts to a ratio comparing the moles of substance Y. So this right here is my mole ratio, which I would look into an equation to find those values that are in those blanks. Okay, so if I want to balance the following equation here, I've got H2NO produces H2O and N2. So draw your line, H2, so that's 2 H's in a box, NO, so that's NO in a box, H2O, that's 2 H's and an O in a box, and N2 is 2 N's in a box. So I've got 2 H's here, 2 H's here, 1 N, 2 N's. So I need to add another N on the left, but I also have to add an O. So that gives me 2 N's, but on the right, I've got 1 O, where on the left I've got 2 O's. So I need to add another O here, and 2 H's are attached to it. So I've got 2 O's, but that, as a result, gives me 4 hydrogens and only 2 on the left, so I need to add 2 more. There we go. So now I've got 4 hydrogens here, 4 hydrogens, 2 nitrogens, 2 nitrogens, 2 oxygens, 2 oxygens. Everything appears to be balanced. So my coefficients would be 2, 2, 2, and 1. How many moles of nitrogen form when 6.55 moles of nitrogen react with hydrogen? So I'm given 6.55 moles of nitrogen, and I want to convert that to moles of nitrogen. Okay, so I'm going to set up my T-chart. And I'm given 6.55 moles of nitrogen monoxide, which is NO. I bring the unit down, moles of nitrogen monoxide, and I want to convert to moles of nitrogen, which is just N2. So this is my mole ratio. Okay, so when I look up at my equation, I see that I've got, where's N2? 1 mole of N2 and 2 moles of NO. So the ratio is 1 to 2. So the math becomes 6.55 times 1 divided by 2, which gives me 3.275 moles of nitrogen gas. All right, so now we're looking at the formula. Carbon plus 2 moles of hydrogen gas produce 1 mole of methane. So here I want to write the general equation for moles of X to grams of Y. So now you're looking at moles of one substance to grams of Y, something different. So now we're going from 1 unit of one substance to a different unit of a different substance. Okay, so I'm going to lay out the T-chart here. So we're going to always start with what's given to me, which is moles of X. So I'm going to write an unknown value, moles of substance X. And then like we practiced, I'm going to bring down the unit, moles of X. Now, I want to convert to a different substance. The only way that I can do that is if I go from moles to moles. So using my mole ratio, I'm going to convert from moles of X to moles of substance Y. I bring down my unit. So my unknown value, moles of Y. And now, using my molar mass equation, or conversion, I can go from moles of substance Y to grams of the same substance. So this right here is the mole ratio, and this is the molar mass. Okay, we'll look at some examples here on the right. All right, so on the top right, practice problem number 1, it says find the moles of hydrogen gas that react to produce 3.55 moles of CH4. Okay, so I'm going to rewrite the equation so I don't have to keep going back and forth. It was carbon plus 2 molecules of hydrogen produces CH4. Now let's just double check that it's balanced. I got 1 carbon, 1 carbon, 4 hydrogens, so it is balanced. So my coefficients are 1 carbon, 2 hydrogens, and 1 methane. So I want to find the moles of hydrogen that react to produce 3.55 moles of CH4. So I'm going to start with what's given to me. I'm given moles of CH4. And I want to find moles of H2. So, set up a T-chart. Start with 3.55 moles of methane, CH4. And then I'm going to rewrite moles of CH4. And I want to convert from moles of one substance to moles of something different. So I can use my mole ratio to go from methane to hydrogen gas. So the mole ratio of hydrogen to methane is 2 to 1. So 2 to 1 goes here. This is my mole ratio. Okay. Now I calculate. 3.55 times 2 divided by 1 gives you 7.1 moles of hydrogen gas. Oops. There we go. Okay, let's look at another problem here. So now it says how many grams of hydrogen react to produce 2.5 moles of methane. So this information here, 2.5 moles of methane, is given to me. I want to figure out how many grams of hydrogen I have. So now I'm going from moles of one substance, CH4, to grams of something completely different. So I'm changing the unit and the substance. Okay, so I'm going to start with T-chart. Okay, I'm going to list what's given to me is 2.5 moles of CH4. So 2.5 moles of CH4. And then I'm going to bring down moles of CH4. And I know that I want to go to hydrogen, so my only opportunity to go from one substance to the next is if I use my mole ratio. So here's where I'm going to go from methane to hydrogen. Two different things. Okay, so for that, I look at my mole ratio up above, and it's telling me that I've got 2 moles of hydrogen and 1 mole of methane. So again, my ratio is 2 to 1. So 2 to 1. Okay, I'm going to keep going because I'm currently at moles of hydrogen and I want to go to grams of hydrogen. So I'm going to bring down my unit. I'm going to write moles of hydrogen gas. And now I know I can go from moles of hydrogen to grams of the same thing. And I know that because this is a conversion factor that we know. This is the molar mass conversion. This is the mole ratio. Okay, so in 1 mole, if I'm looking at my molar mass conversion, 1 mole of hydrogen gas is equal to, well, I've got 2 hydrogen atoms. So 2 hydrogen atoms is 2.016 grams. So now if I do the math, I got 2.5 times 2 times 2.016 all divided by 1 times 1. And when I multiply those together, let me scoot this over a little bit. Oops, if I can, let's try that again. There we go. So 2.5 times 2 times 2.016 gives me 10.08 grams of hydrogen gas. Okay, so there were 2 steps here. So remember, we went from moles of one substance to grams of something different. So first step is your mole ratio based off of the coefficients in the equation. Once you have your mole ratio, then you're converting to your molar mass, which is found on the periodic table. And the reason it's 2.016 is because hydrogen is, let me write that over here. Hydrogen by itself is 1.008, but I've got 2 hydrogens, and that gives me 2.016. All right, let's try our last one here. Practice problem number 3. It says determine the mass of methane produced when 1.85 moles of hydrogen reacts with carbon. So this is given to me. So I'm given the amount of moles of hydrogen, which is expressed H2, and I want to determine the mass of methane. So now I'm going to grams of CH4. So different units, different substances. So just like we've practiced, set up your T-chart. Okay, so I'm going to write in what's given to me, which is 1.85 moles of hydrogen gas, and I bring down my units, moles of H2. Now this is my opportunity to go from H2 to a different substance by using my mole ratio. So based off of the ratio up above, I've got a coefficient of 1 CH4. Let me zoom out a little bit here. So I've got 1 CH4 and 2 moles of H2. So my ratio is 1 to 2 or 2 to 1 depending on how you're reading it. All right, so when we look back down here at the bottom, I've got 1 mole of CH4, 2 moles of hydrogen gas. So I'm going to continue on. I'm going to bring down my unit, moles of CH4. And now my last step is to go from moles of CH4, I'm at methane, that's where I want to be, and I can convert to grams of the same substance. So in 1 mole of CH4, now you got to figure out the mass of CH4. So carbon is 12.011, and there's only 1 carbon, so that's 12.011. Hydrogen is 1.008, and there are 4 hydrogens, which gives me 4.032. And when I add those two together, I get 16.043. So that is the molar mass of 1 mole of methane. So now I do the calculation. Do 1.85 times 1 times 16.043, all divided by 2 times 1, which gives me 14.84 grams of methane. So now I've successfully converted from moles of hydrogen to grams of methane. 2 different units, 2 different substances. That's the mole mass conversion.